Welcome back to OCR MEI Further Mathematics B. Today we are doing Chapter 6.1, Evaluating Improper Integrals. So evaluating improper integrals are a new concept to A-level. Before the new spec, they never asked anything to do with improper integrals. So we do not have limits towards infinity, we do not have limits towards a 1 on 0 value, etc. But now we do, so we need to make sure we can do those. For some questions, you will need to break them down into parts and do them in two different domains. So I'm gonna show you one of the examples there, and I will give you guys some questions to follow up on. So let's take this as our first example. Integrate between 1 and minus 1 of x to the power minus 1/2 dx. So this kind of looks like a certain expression that we've learned before, 1 over x, where the curve sort of look like this. Oops, they're smooth curves, by the way. So we have two asymptotes, x-axis and y-axis, and we need to integrate between 1 and 0, 1 and negative 1 on the x-axis, which gives us a problem. We have an asymptote in the middle, and the definition of integration requires you to find a continuous curve. So this will not be continuous. In order to find the integral, we need to split it into two such that they are continuous curves. It is a continuous curve from 1 to 0, and it is a continuous curve from minus 1 to 0. And technically it is limit approach 0, but I'm just going to call it 0 for simplicity's sake. So right now what we need to do is to find this integral. It is equal to 1 to 0 of x to the minus half dx plus integral of 0 to minus 1 of x to the minus a half dx. So with that, we can look at how to carry out these expressions. So we have an issue with 0 substituted onto the x, because 0 to the power of negative gives us infinity, which means that rather than doing this straight away, we need to write down this expression, limit of x towards 0. So we're technically not using x as 0, we're just talking about the value of x tending towards 0. So basically it gets very, very small. We have x to the minus a half integrated is x to the plus half times 2. With that, we have 1 and a value x. So x tends to 0, we keep this as x. So leave it in algebra form after we've expanded. Then add the same thing, limit of x tends to 0 of 2x plus a half of x on minus 1. So we can expand this whole thing as just a 2, take 2x to the half Then we have the right add 2x to the half. Then we have a minus 1 here, so we have a square root of minus 1 times 2, so we have to take 2i, if I'm not mistaken. Let's see, minus 1 square root is I, 2i, yeah, that works. So we have, also we need to write down limit of x tends to 0 because we did not define what x is otherwise, which is equal, this whole thing will be equal to 2 take 2i, so that would be the limited value of the integral. This is the result of this evaluation. There are also others that requires you to find a limit from an infinite to a 0 or something similar to that. You do the same thing with this limit. Instead you have x tends towards infinity, then you do the same thing, leave it as x, then do the algebra, then things should probably cancel, or it would, since it tends towards infinity, it will go to 0, so you ignore that term, and so. It happens a lot. Maybe you have an expression of x to the minus 1 where x tends to infinity, then you have 0 here immediately. So that's how you do the infinite domain integrals. One thing that, again, I need to remind you, this is a new concept in A-level. It's not, it's probably guaranteed to pop up in the first exam, which is the 2019 summer. So do make sure you know how to do this one if you're on set year. Write down the lim symbol because that is a requirement. If not, you're doing wrong mathematics and they will not give you any marks for doing improper math. That's why you need to do a lot of practice questions on this topic. There wouldn't be a lot of by ways of practice questions because, again, you do not really have a trial paper to do. Your teacher will probably get you something along the lines, but yeah, make sure, just if you want more practice, go online and look for questions. Now it is question time, so you have some questions to get practice on. The first one is relatively straightforward. The second one is very challenging. The second one is actually really difficult. I will tell you exactly how to approach this question in the answers, but for now, just give it a go. It's not gonna be straightforward. You'll need to use complex numbers, you'll need to use partial fractions, integration, and improper integrals. So you have technically 4 things to practice on all in one question. So that's really helpful in terms of skill. So I'll leave it to you, and I'll show you the answer in 5, 4, 3, 2, 1. So here we go. Question 1 is one on e. That is not that difficult because e to the minus infinite is 0. The value tends towards 0 anyway. So that would give us e to the minus 1 as our solution. For the second one, it is once again very complicated. First of all, the first step you should be using on the approach is to do partial fractions, because that is a difference of 2 squares. So rather than having 1 on x squared take 1, you have 1 on x plus 1, x minus 1. That split into a half lots. So let's see, I have a half lots of 1 on x take 1 on x add 1. So that should be your standard integral. Now you need to put in the limits. So first of all, let's evaluate how this curve looks like. So we know because it is a standard 1 over, let's have a look at first of all just x squared take 1. X squared take 1 looks sort of like this, but if we do a 1 over, then we have an asymptote here and an asymptote here, so we have technically two asymptotes. We're looking at the domain 2 to 0, so we have one asymptote at 1. So this is helpful to know, which means that we need to split our domain into two sections. First section is 2 to 1. Second one is 1 to 0. So we have these two domains to take care of. With that said, however, we need to look at the one asymptote. We plug in limits. So after you've integrated this whole thing using the standard method, you should get natural log of x take 1 minus the natural log of x plus 1. The trick here is to combine this log into the natural log of x take 1 on x plus 1. So that would save you a lot of effort. This said, we have, let's see, where am I on my notes? Make sure you have the half as well. So you've got this sorted, then we have, after putting in the top integral of 2, we have half lots of natural log of a third. Add this thing, this whole section denotes u. Add u. Then the second part, from 1 to 0, we have u. Actually, this is not add, this is take away u. This is add u, take away the natural log of minus 1. So essentially what we have here, after consolidating the u, so we're done with the improper integral, now we're just algebra. We have a half lot of natural log of a third take half lots, actually this is half lots, isn't it? Half lots, so we have just a natural log of minus 1 on the right. So right here we can do two things. One of them, let's see, what am I doing here? The first thing you need to do is to take care of this one. So you have natural log of a third is essentially negative of natural log of 3, because of 3 to the power minus 1, you drop the power to the front. So you have half lots of minus ln 3. Then we have take natural log of minus 1. This one is the most where most people will trip, because minus 1 in complex is actually, remember the exponential form, e to the pi I. So by taking the natural log of minus 1, you take the natural log of an e, so they cancel out to give you just pi I. So you have natural log of minus 1 is pi I, and hence you have this solution. This is actually add, my bad. Yeah, so hence you have this solution. It's again, very complicated. It's a good practice to do, and yeah, this is a new content, as I said, so I'm not sure how difficult the questions would be. If I were the examiner, I would set question sort of similar to this difficulty, but it might be a bit too difficult, I'm not sure. So yeah, that's it for this video. I hope you've learned something. If you have any questions, do let me know in the comment section below, especially for this chapter. This is very new, and do ask if you have any confusion whatsoever. But for now, thank you very much for watching, and I will see you on my next one.